Hi, welcome to building and running your own image classifier, a tool to classify images using deep learning. My immediate goal is to help you build and run your own image classifier using free resources on the internet. My longer-term goal is to show you that the field of deep learning is for everyone, not just data scientists or machine learning experts, and that you don't need to have deep pockets or large amounts of data in order to do deep learning. In order to follow along, you don't have to stop and rewind this video. I've written an article that will guide you through the steps. Just click on the link in the description and use that as a guide. By the way, this is a quick walkthrough, so I will be rushing through the different parts of the article. Don't worry if you can't follow the first time around. I just want you to see the entire process from building the image dataset all the way to running the application. When you're ready to actually build it, just pause it and work through the different sections of the article. We'll start from the top and go through each section pretty quickly. Are you ready? First, we'll start with a demo of what we're building, a cat-dog classifier. Let's click on this link to Binder, which starts our application, which might take a while as it's spinning up the application. As you can see, this is a simple application where we can upload pictures and it will classify the image for us, whether it's a cat or dog. So let's try uploading some images from my files. As you might notice, it's very good at classifying cats and dogs, but if I pass it a bear or a pig, it'll try to guess whether it's a cat or dog. So bears are more like dogs, but pigs are more like cats. Now that you know what an image classifier does, let's start building it. In order to build your image classifier, we will be using free resources on the internet. I'll introduce them as we go along, but in order to use them, we will need to create a Google account. If you don't have a Google or Gmail account, you can click on the link and create one. You will also need to create a GitHub account, and you can also do that by clicking the link in the article, but you can do that later. One of the tools that we will be using is Binder, which is what we used to run the cat-dog image classifier we ran earlier. Another tool is Colab, which is what we will use to collect our images and build our image classifier. Let's start by collecting images. Open your Colab notebook by clicking the link in the article, which should open it in a new tab. A Colab notebook, also called a Jupyter Notebook, is an interactive document, much like Google Docs, but aside from containing text, we can also run programs in it. Our first notebook, aside from containing the instructions which I wrote on how to use it, also contains the code that does the actual steps to actually fetch images over the internet and collect them into a dataset. Here, we first need to fill out what search terms we will use to collect the images. By default, we are collecting images of cats and dogs, but we can change them to whatever we like. We will also specify the project name so we can build lots of classifiers. We just need to keep them in separate projects. Once we have finalized the search terms, we can start the notebook by running the menu item runtime run all. This message warning will pop up. Just disregard this warning. Once the notebook starts running, an input box as well as a link to your Google account will appear. Click on the link and authorize the Google Drive File Stream app to access your Google Drive. Your Google Drive will be where we will store the images you collected as well as your image classifier. After you've authorized the app, it will show you an authorization token. Click on the clipboard button to copy the token to your clipboard and open the previous tab showing the Colab notebook. Paste the contents of your clipboard into the input box and press enter. This will now connect your Google Drive with your Colab notebook, allowing you to save the images to your Google Drive. If you scroll down on your notebook, you can see that it actually is executing some of the programs in the background and will notify you of its progress. If you click on the Show Code link, it will expand to show you the actual code it is running. Once it completes downloading the images, it will then zip up the images and save them to your Google Drive. Once it completes that, your task is done and you can check your Google Drive that the files have been saved. You can then run the factory reset runtime in order to close down your notebook. Once you've closed down your Colab notebook, you can open your Google Drive and you should see the zip file containing the images. Now that you've collected your images, your next step is to clean the images. The images collected are not always the right ones, so we need to remove the wrong ones or reclassify them to their correct categories. Click on the next notebook as listed in the article. Again, the notebook contains the instructions on how to use it. We'll need to specify the project. If we changed it in the first note, we'll have to change it here as well. For now, let's leave the dataset type to raw. Once we specify those items, we can launch the notebook. Again, we can disregard the warning. It will also display the link and input box to authorize the Google Drive app Collect Colab. Once the token is pasted, we can scroll down the notebook to see the image cleaner widget. We can see some of the images that have been downloaded. In particular, these are the images that our image classifier is not so sure about. We can either delete them if they are the wrong images or reclassify them if they have been misclassified by clicking on the Apply button. We will need to do this for all the categories and for each subcategory of valid or training dataset. Once we have done this, we can continue by clicking on the next section and running the Runtime Run After menu item to complete the process and save the cleaned images to a clean dataset and copying them back to Google. We can check the cleaned image dataset in our Google Drive, after which we again click on the factory reset runtime to close down the node. With the clean dataset, we are now ready to build the final image classifier. Again, we go back to the article and click on the notebook to build the image classifier. Now, to build this, we will follow more or less the same instructions, including the setting of the project name and authorizing the Google App Drive to connect to Colab. Again, we will go through the same steps of connecting the notebook to the Google Drive while we watch it build an accurate classifier. If you notice, the image classifier now shows you better accuracy, but it takes longer to build. Once the notebook completes, we can check that it built and exported our image classifier. After checking that the image classifier has been exported, we can close down the notebook and proceed to the next step, which is to test our image classifier. After opening our notebook to test the classifier, we again run it and connect the Google Drive to the Colab notebook. Scroll down the notebook and it should show a simple app that will allow us to upload images and classify them. Let's test the app by uploading images to see if our classifier classifies them correctly. Once we are satisfied with the image classifier, we can close down the notebook by clicking on the menu Factory Reset Runtime. So now we have an app that classifies images. In part 2 of this series, we will export our app from Colab to GitHub so that it can run unbinded. Before ending this, I'd like to acknowledge the tools we used. The software used to clean your data and build your classifier is based on the FastAI Python package written by Jeremy Howard and Sergey Google. The Jupyter Notebook environment that enables us to run our interactive documents to build our images won the 2017 ACM Software System Award and is widely used by scientists, researchers, and students around the world. The software package used to collect the images, called JMD Image Scrape, was written by Joe Druckwell. Finally, if you liked the video, and especially if you were able to build your own classifier, ping me on Twitter or leave a message here. I'd love to hear from you.